Okay, welcome to grade 10 Applied Math. We're in Unit 2, Chapter 4, and Lesson 4 is all about, Chapter 5 and Lesson 4 is all about solving problems involving linear systems. We've been solving problems by graphing and by a substitution method and by elimination. And today we'll be choosing between those options to solve these problems. To begin with, we have a recap of last lesson, and that was from elimination. So we'll quickly go through elimination because it will help us with this lesson again today. So when we look at these two numbers, we see that these two equations, we're always looking for a pairing that um, works well to eliminate. The 2 and the 5 would require more work, so we look at the 4s, and the 4s will eliminate each other. If the signs are the same, if signs are same, then subtract. Okay, so if we have equation 1, 2x minus 4y equals 8. And look how much space I'm giving here. That's kind of important, just so you can indicate what your function will be, what your operation will be. So in this case, we're deciding to subtract because we need this to be a negative and a positive. So by making a subtraction, we're actually changing each sign. And then think of it as addition after that. So 2 minus 5 is negative 3x. Negative 4 plus 4 is 0y, which really just cancels out. And then 8 minus 2 is 6. So negative 3x equals 6. We divide both sides by 3, and we get negative 2. All right, we sub x equals negative 2 into, 1. Now I'm going to choose 1 because 1 just looks a little easier to me. So it's going to go in for the x. So 2x minus 4y equals 8. 2 times the number we're substituting in, negative 2, and then continue with the rest of the equation. So now negative 4, these two multiplied, minus 4y equals 8. All right, and then we're going to bring our negative 4 over here. Negative 4y equals 8 plus 4 now. We have negative 4y equals 12. We're going to divide both sides by negative 4. And we have y equals negative 3. So therefore, possible solution is negative 2, negative 3. I say possible because it also asks for a check. So if we're going to do a check next, we can do left side equals right side. And let's say we used equation 1 before, so maybe this time you want to choose equation 2 just to sort of make sure it works with both. All right, so 5x minus 4y equals 2. So 5 times what we think x is going to be is negative 2 minus 4 times what we think y will be. So negative 10 plus 12 is the difference of 2. Left side equals right side. So therefore, now we can clearly say that the point of intersection is negative 2, negative 3. So it's worthwhile to check these sometimes. And it's a good tool moving forward in math to have the knowledge of how to check your answers. So let's move on now to the actual lesson. Really, we're just summarizing what we've already learned in the whole unit in order to solve more complex problems. So by the end of today's lesson, we'll be able to solve real-world problems involving linear systems using the substitution or elimination method. So one thing we talked about, we always talk about when we do word problems is defining the variables. So the first thing we want to do is read the question really carefully and pick out some information that's important to know. Tickets for a play are sold at a cost of $5 per adult and $2 per children. If 250 tickets were sold and a total of receipts were 767, how many adults and how many children were sold? Okay, so how many children attended, sorry. So one thing you want to do is if we're saying $5 for every adult ticket, every adult ticket was $5, every child ticket was $2, and we know that 256 tickets were sold. We know that a total of 767 dollars were made. So we almost need two types of equations. We need a cost equation. We need a ticket number of ticket equation, number of tickets, and we need the total earnings, let's say, as our second one. And so we have to kind of come up with two equations that will represent this. So let's first of all say, if we need to know how many adult tickets there are and how many children attended overall, then those are represented with tickets. So I was choosing a different color there. Let A represent the number of adult tickets sold. Now, just looking again at the question, it says how many adults and children attended. So maybe we'll actually reword that. Adults attending. Why not? Every adult should have a ticket, right? So let C represent the number of children attending. Very good. Okay, so what could our equation 1 and equation 2 be? So think about, could you come up with two equations? So an equation for a number of tickets sold. So maybe pause the video and see if you can come up with an equation for number of tickets sold and the total amount of earnings. All right, I'm back, and let's see if you came up with something like I am going to say. So we know that the total number of adult tickets plus the total number of children tickets is going to equal 256. We know that every adult ticket brings in $5. We know that every child ticket brings in $2. And we know on that day when they sold all their tickets, they had that much. Okay. So in this case, we want to think, when we see this as an equation, what do you think we could do better, substitution or elimination? And why don't you contemplate that? You can pause it. You can try to do the solution on your own, the way you think, and then I'll let you know. I'll demonstrate what I would do. Okay, so if you tried it, that's great. Here's what I would do. I see that A and C, either one of them is very easy to isolate. So my next step would be to isolate the A, let's say. So I want to isolate A. So A is equal to 256, and the C would come over, of course, minus C. Okay, and then I'm able to substitute that whole bracket in for my number 2. Nothing's going to change on this one. 5A plus 2C equals 767. Okay, so going forward, our next step is to say sub 1 into 2. All right, so let's list 2. 2 is 5A plus 2C equals 767. So it's A that we've isolated. So 5, and then make your bracket larger to substitute in. All right, and we're going to put this whole thing into here, right? So we're going to take this whole thing, put into there. 256 minus C. All right, so the next thing we have to do is distributive property. So 5 times 256. Now, yeah, you might need your calculator for this. 256 is 1280. And then the next one, expand, or distribute, sorry, negative 5c. Okay, now we have everything else after, stays the same. All right, we gather like terms, so we'd want to bring the 1280 over here, and we want to combine these two. So we have a negative 3c equals, it's going to be, I'll write it out so we don't lose track of what we're doing here. Minus 1280 is going to be negative 513, and 3c is there. Okay, so we want to get rid of the 3c. And there we go. So let's try this. 513 divided by 3 is a nice even. The two negatives make it positive, so 171. Okay, so we know now how many children. We could, well, no, we can't stop here, but we know part of our solution here, the number of children. So, children attending. So, we all know what we do next. We have to substitute that into the next step. So, let's go with that. So, sub into, I don't know about you, but I think equation 1 is much easier to work with. So let's use that. So we're going to use in for C, A plus C equals 256. You could even put it into this one since you've already done the isolation. That would actually save you a step, but I didn't choose to do that. So here we go. So A plus 171, let's say highlight it in green so that you can really see it, equals 256. Okay, we're going to bring this over. So A equals 256 minus 171 is 85. A equals 85 adults attending. There we go. So, therefore, actually, we're just going to rewrite this, right? So, therefore, 85, oh wow, Marker's not cooperating. 85 and 171. 171. Again, I'm not sure why this is happening. 171 children attended the play. There we go. Okay, so there's an example. It's a lot of work. These questions aren't easy. Defining those first two equations is crucial to getting this right. So let's tackle the next one. Okay, question number 2. A golf club charges its members an annual fee and a green fee for each golf game played. In 1 year, Bob played 12 games and paid 814. In the same year, Sue played 29 games and paid 1,188. What is the annual fee? What is the green fee? Okay, so what we want to say is let one of these be the annual fee and let the other be the green fee. So why don't we just use the letters that they are giving us? So let A represent the annual fee. My marker's working better again. Fee, okay, in dollars. Let G represent the green if you're not a golfer, you have to understand. So there's an annual fee to be part of the club, to be a member, and every time you show up, you pay a green fee. So if you're not a member, maybe your green fee would be like a whole bunch more money, or maybe you wouldn't be allowed at that club because it's a private club, right? Different clubs work differently. Anyway, it's important to know because some people wouldn't know what a green fee would be, so they wouldn't even understand what we're talking about. It's important to understand the context of the question. Okay, so instead of saying 1 or 2, maybe we're doing, yeah, we can call it Bob. So what would Bob's equation be? Well, he went how many times? So they only pay their annual fee once. So there's only one annual fee. 1 times whatever that is. How many times did Bob go? Bob went 12 times. So he has 12 times for 12 green fees. And in total, he paid 814 the whole season. Okay. And Sue, well, she still only has to pay her annual fee once, and she went 29 times to golf and paid 29 green fees for a total of 1188. Very good. So we have equation 1 now, equation 2. Now, we always sit back and ask, like, what should we use? Substitution or elimination? Here, it looks like these line up really nicely, and our A values are equal. So I think elimination would be a great tool here. Okay, the A values are A value is same, right? So that's why we want to do that. So we just have to ask ourselves, are we going to subtract or add? Well, the signs are the same, so we are going to subtract. So that makes this a negative, this a negative, and this a negative. All right, well, 1 minus 1 is 0a. 12 minus 29 is, oh, it's going to be 17, negative 17. Negative 17. And, oh, excuse me, I will do our calculator here. 814 minus 1,188 is negative 374. I forgot to say it, but at any point, if you think you can do this question all by yourself, you should always pause the video and then go ahead of me and see if you can solve it, and then continue, or pause it if you get stuck, and then see where I come up, where I go with it. So let's divide both sides by negative 17. And it should go evenly. Let's just try. So 374 divided by 17 is 22. So we're going to have G equals, again, two negatives make it positive, two negatives make it positive. G equals 22. So that means the fee for one green fee is $22. Not bad. That's not bad if you golfers out there. You know that that would be fairly reasonable. Okay, so let's substitute. Let's substitute into one of them. Doesn't matter which one. Which one do you think has nicer numbers? Probably one. One looks like smaller numbers. So 1a plus 12g equals 814. So 1a, we're going to now make a bracket for the g. 814 doesn't change. And we're putting that 22 into here. Get your calculator ready. 1a plus 12 times 22 is 264. All right, good. We're going to bring this over. This 264 over here to subtract it. All right, and we have 1a equals 814 minus 264 is 550. Okay, so now we know that's our a value. So in other words, it costs each member $550 to join the club and $22 per green fee. So we can make a statement now. Therefore, the annual fee is $550 and the green fee is 22. You might be noticing a pattern, like a lot of what we've done up to now in the course, there's always been a dependent variable and an independent variable, meaning the distance depends on the time traveled, or the time worked depends on how much, or results in a fee, earnings, or cost. And we always have a dependent, an independent variable, and a dependent. In these two last examples, you'll notice that there is no, one variable is not dependent on the other. They're just sort of both codependents, covariance. So in that case, that's where we're seeing some of these different types of equations. Anyway, word problems are result in long questions, but this was a short lesson to give you two common examples of what you could see when you're taking on word problems. Okay, thank you for watching.